And welcome everybody to the Daily Space Weather. We've got some new sunspots rising in the northeast, as well as growth of the existing sunspots. That and lots more coming at you from the Smash News Network, least busted name in news. Let's blast through some space weather. Sunspot 2924 has grown. The likelihood of solar flares goes up with it. Coronal mass ejection watch still in effect. And some active regions. So we've got also some small sunspots forming up here north of 2924 and 2925. Looking at the colorized magnetogram, we don't see any major activity in the northern hemisphere. There is a North Pole-oriented current sheet having a bit of a tug-of-war. Solar plasma having a tug-of-war between the North and South Pole. And there you can see the growth of sunspot 2924 especially. Not too far from being directly in the Earth-facing zone. Here's a close-up of it in 171 angstroms from the SDO. Classic imagery. Radial flux has come up precipitously to 94, so a big increase in the radial flux. We'll see the sunspot number rising today. Also, there's the one-year chart. The black line is the radial flux. The red line is the sunspot number. We can expect to see that rise as well in the coming day or two. No space weather storms forecasted. There was a minor coronal mass ejection strike. We'll get to it. It was one of the ones that we forecasted before it left the solar corona. Next, looking at earthquakes, the largest of the past 24 was a 6.1 at Nicaragua. That happened at 1625 Universal Time yesterday. No other quakes above a 6 magnitude. In fact, barely any even over a 5 magnitude, it looks like. So pretty calm as far as earthquakes go. There was a 5.1 at New Zealand and a 5.3 at the Mid-Atlantic Ridge. So otherwise, pretty calm past 24 hours for earthquakes. Next, volcanoes. And let's see what's erupting. Shivaluch is exploding, producing a 13,000-foot ash plume. Subanosejima, 4,000-foot ash plume over the Ryukyu Islands. Popocatépetl now back on the list, producing a flight level 200, a 20,000-foot plume of volcanic ash over central Mexico. Santiaguito in Guatemala, 15,000-foot ash plume as Santiaguito explodes. Nevado del Ruiz, no volcanic ash clouds observed. Don't assume it's not erupting if you are in Colombia. Sangay exploding. Flight level 190, 19,000-foot volcanic ash plume over Ecuador from Sangay, 15,000-foot ash plume from Revenador over that same country as Revenador explodes. Sabancaya also exploding, 24,000-foot ash plume over Peru. Please don't fly your hang glider over the Sabancaya caldera. Please don't pole vault the Nevados de Chilean caldera. It's exploding intermittently and producing a 12,000-foot plume of volcanic ash. Please do support the channel via our links. You can find them at smashamash.com. Smash staff and I would like to welcome all of our viewers to the Neo Renaissance. Congratulations on realizing the channel exists and getting around all the pathetic censorship on social media to find us. If you'd like to support the content, consider becoming a member of the Smash team. We just put up a post only for gold level members. Thanks to our gold and silver Smash team members, as well as our gold annual paid-up subscribers. That's all you get as far as teasers go. If you want additional information, like on Patreon, become a member over at smashamash.com/smashteam. The website is simply superior. It's the official funding source for the Smash News Network, least busted name in news. Next, blasting through some magnetic data. We've been seeing some higher lows and some average highs here, so a bit of an uptick there in terms of the lowest readings on the GOES 16 and GOES 17 magnetometers. Here's the North Pole current sheet I was talking about yesterday. Yeah, I forecasted it. There in the latest image, you can see this little North Pole current sheet coming through. This might go away again, as again there is a bit of a magnetic tug-of-war going on in the eastern limb of the sun. It's magnetic. And the plasma that comes out of the sun is oriented to one polar field or the other. Earth remains in a South Pole current sheet. We'll have to see what goes on with the activity rising in the east to make any future forecasts. Keep in mind the magnetic environment can suddenly change with basically no warning. There's a line-of-sight ecliptic plane field plot. If you're getting any warning, it's probably from our channel. I think nobody else is forecasting it because they don't know how. You must immerse yourself in the data, folks. If you immerse yourself in the data, you may get answers to questions not even asked, as our channel has done. Next, looking at coronal holes, you can see some South Pole-oriented ones here in the earthly zone ahead of sunspot 2924 and behind sunspot 2925. None of those are transequatorial yet. Here's a great view of coronal holes in 193 angstroms from the SDO. Again, there is some activity rising up here in the northeast, and that could affect the heliospheric current sheet's polarity. Next, looking at sunspots, you can see these umbrae are spreading apart. That increases the likelihood of flaring, in my opinion, as there is plasma magnetically suspended in between these areas, and as these move farther and farther apart, the chances that that plasma will collapse grow, in my opinion. Here's a close-up of that. You can see additional umbrae forming there. 2925 consolidated a little bit. 2924, which is this one here, continues to grow. That causes the likelihood of solar flares to go up. We've only seen some C-class intensifications in the past 24. And here's another close-up of the most active region of the Sun, the southeastern limb, in 94 angstroms. A great wavelength to view solar flares. Speaking of solar flares, again, only 2 minor C-class intensifications here over the past 24 hours, and indeed the past 3 days. We've only seen 2 minor C-class solar flares. Don't be surprised to see something much larger, like an M or even an X-class flare. At the moment, that sunspot is quite huge. That could cause relativistic protons to make it all the way to the Earth geospace. Nothing like that happening for quite a while here. Let's look at the real-time solar wind next. And again, we did see, this looks like a minor coronal mass ejection strike here. You can see a change in the plasma temperature, as well as a sudden uptick in the speed and density. So there's one of the coronal mass ejections that we said was going to strike Earth. It was pretty minor. It barely caused any sort of a blip. Current conditions are very slow and very diffuse solar wind, so almost down to 300 kilometers per second. Current reading is 309 kilometers per second. Very slow solar wind and quite diffuse, not dense, at just over 3 1/3 protons per cubic centimeter, the current solar wind density. KP index has been mostly at 0 here over the past about 36 hours. KP only got to 1. That's a measurement of global geomagnetism if you're a new viewer. And here's the geospace over the past 4 hours. Looks like another minor coronal mass ejection strike there. There were no less than 3 headed toward the Earth. We're still expecting another strike or 2 in the next day or 2. Remember, folks, our specialty is not forecasting the trajectory or the speed of coronal mass ejections. It's to forecast them before they exit the solar corona. Anyway, that's the last 4 hours of the geospace. Here are the ground magnetic perturbations. That was the magnetic moment from space. Here's the magnetic moment from the ground. And like the last frame, it's 4 hours of data. We show it daily to immerse you, the viewer, in the data, to help tie the variables together. Geophysics. It can be a bit complex. Some of it even counterintuitive. Next, a diagram of the solar system. We're going to show you a 1-week forecast here. Venus will be right between the Earth and Sun. The inferior conjunction, is it? The inferior opposition? Whatever it is, the Earth will be, Venus rather will be directly between Earth and Sun this weekend. We've already got some fantastic images. That's where things will be in a week on January 14th. Today's astronomy picture of the day at apod.nasa.gov is indeed of a penguin enjoying the eclipse down here in Antarctica and advertising its status. apod.nasa.gov if you want to check that one out. Great image there of the Antarctican lunar eclipse. Next, a star chart. If you're up before dawn, you may see Mars rising ahead of the sun. You can see how close Venus is at the moment, making it a bit difficult to photograph from Earth because you don't want the sun's rays going in your non-solar filtered telescope. Next, looking at a coronal mass ejection watch. We're going to show you the view from stereo A here at Lagrange point 5 and the LASCO SOHO C3 at Lagrange point 1. Great view of Venus there on the LASCO C3, which is on your right. Again, that's located between Earth and Sun at L1, Lagrangian point 1, the gravitational equilibrium point. Also, the ACE and the Discover are located there. Stereo A here on your left. Huge plume of plasma here. Again, coronal mass ejection watch in effect. And here's a great view of Venus in its crescent mode, taken on January 5th. You can find a link to that at spaceweather.com. Today's cosmology segment's going to be brief. It's going to be integrated to the daily space weather video. We've picked another random object between 1 and 76, the black hole candidates list on the Neil Gehrels Swift-Bat X-ray Observatory Transients Monitor page. Number 74 is, I believe it's V404 Sig, Z404 Cygni, I believe. And you can find a link to this at the main page at the Neil Gehrels. V404 Cygni, the low-mass X-ray binary / black hole candidate. These are the X-ray emissions from that low-mass X-ray binary / black hole candidate. You can see it did have some interesting outbursts here back in mid-year around 2014. Some major outbursts from that. There is the 30-day X-ray graph for V404 Cygni. Let's take a look at this in radio. So the Cygnus arm of the Milky Way galaxy is very, very bright. You can see how bright that is. The galactic plane down here. And off in the outskirts of the Cygnus arm is where we have V404 Cygni. That is the 11 centimeter Effelsberg radio survey. Let's take a look at this in some other wavelengths here. Here's some more radio imagery from that area. This is 217 gigahertz. Rather dark in that frequency, really. Next, we'll bring up the composite 2-mass infrared spectrum here. 3 different wavelengths here in infrared from the 2-mass. And there's the heat signature from that low-mass X-ray binary. Perhaps a shared plasma envelope situation going on at V404 Cygni. And this is indeed bright optically. Here's a composite image from Pan-STARRS, bands Z and G from Pan-STARRS. You can see that slightly oblong object there. The low-mass X-ray binary. Not so bright in near UV, that's the Galix. It's pretty dark in ultraviolet. And in X-ray, here's a great view from the Chandra. You can see that's a very bright X-ray source there. And possibly some jet structures there, as we see these lines here do not look like artifacts. That's V404 Cygni, the low-mass X-ray binary. Entry number 74 on the Black Hole Candidates page, which you can link to at the main transients page at the Neil Gehrels Swift-Bat X-ray Observatory. That's today's cosmology segment. We integrated it to the daily space weather video. Cosmology. It might be stranger than you even think. Next, looking at charging hazards. No charging hazards at the moment. Electron flux is in a more normal level here. Here's a one-year chart to put the electron flux in context. The relativistic electrons measured by the GOES 16 and 17. There's a 3-day chart of that. Pretty normal levels here. Here's the forecast model. No arguments there. Looks like a coronal hole wind stream might be arriving, possibly causing this large dip. We'll keep you posted. Next, the total electron content forecast, showing you the most likely spots for GPS errors. A little bit of chaos happening there in the Southern Ocean, and indeed over places like South America. We'll let it play through a second time here. Total electron content forecast shows you the most likely places for GPS errors, some anomalous errors over North America here once again. And next we'll show you the F ionosphere layer, located about 300 kilometers of altitude. Here's the ionogram. And certainly seeing some anomalies on this as well. It's just one slice of the atmosphere in vibrational frequency. Next, the anomalygram, and you can see lots of low-frequency anomalies here south of the equator. Some high-frequency anomalies here as well, in places like the Central Atlantic, South Central Africa, and over parts of Antarctica. It's showing you anomaly in megahertz from the 30-day median. If you wondered what's going on in the ionosphere, you're welcome. There's the latest image from 1330 Universal Time ionogram, and there's the anomalygram. And let's do bonus features. Bonus feature number 1 is the ground-based solar observatory, part of the National Sunspot Observatory at Cerro Tololo, Chile. Looks like some flaring actually showing up there as those umbras spread apart, as we talked about earlier. Next, the NASA GOES 16 SUVI imagery, quite up to date here. And it's very good at showing plasma filaments in this 304 angstroms ionized helium spectra, part of the ultraviolet light spectrum. Next, your latest intensitygram and your latest colorized magnetogram. Check out the fields on Sunspot 2924. That is certainly capable of producing major flares. That one's becoming more capable as well. Here's a close-up. Quite an active sunspot, and some additional beta-class sunspot groups forming here. Again, likelihood of flares much higher as a result of all of that. And we'll close out with an SDO imagery here of 304 angstroms. Stare at the sun, view our other videos on our playlists, support the channel if you'd like to see these videos continue to exist, become a member of the SMASH team, press like, subscribe, etc. We'll see you soon. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of SMASH News Network, least busted. Name it news.